Now, there are other approaches which can be combined in a real-world evidence scenario, because real-world evidence is usually very abundant in terms of having large amounts of data present. So this makes it ideal for utilization of methods such as machine learning or even AI. So implementing methods such as random forests or even deep learning can be used to augment some of those causal inference approaches that we use. So causal inference, machine learning causal inference, is basically a very simple combination of the approaches that me and Justin were mentioning, so propensity scores, instrumental variables, counterfactuals, combining those with the scalability and efficiency of machine learning models to create something that's called causal machine learning. Now, causal machine learning is still a developing field, so there are huge developments there. Dynamics is high, but it's still a developing field. Many researchers, many institutes and companies are still in the phase of adoption of causal machine learning. But I think huge potential is there, exactly for the reason of we have a lot of data that's created on a daily basis in hospitals, research institutions, and data repositories also store huge amounts of real-world evidence. So methods that can scale the analysis to perform analysis much more efficiently while maintaining these principles that we were mentioning about causal inference, that's one of the most promising areas, I think, in the future. And a lot of developments are happening right now in that field. So I think causal machine learning, or causal ML, as we would alternatively call it, probably causal AI. So causal AI is probably the next topic, because a lot of companies are now developing AI models to mimic human intelligence. And one of the topics, one of the goals that need to be achieved is machines would need to reason similarly to humans. So humans are inherently made for causal reasoning. A lot of things that are happening around us in the world, a lot of phenomena, we are naturally reasoning them causally. What is happening when something else happens? Why is something happening? What is the cause for this disease? How could this disease be treated by targeting a specific cause? So we're naturally doing that, and when machines also start doing that, that will be a step closer to what everyone is calling artificial general intelligence. So a lot of companies are investing in that field too, and I think anyone interested in causal inference, it's a very dynamic field. It's a very interesting field, and it's needed. It's needed for further development of science.